Hello everyone, I'm Jason Sikes, aka the Tech Rancher, and this is the homework solution for lesson number 28 from the course called Raspberry Pi Pico W by the famous Paul McWhorter. Paul does multiple different types of electronic engineering courses along with different types of courses on YouTube. You can find him at Paul McWhorter or on his website page at toptechboy.com. Let him know I sent you. You mean a lot to me. Alright, enough about promoting Paul. Let's go to what he wants us to do for a homework solution. He said he wanted us to make our Raspberry Pi Pico W wireless. As you can see here, there's no USB port connected over here by my finger. I could zoom out a little bit, but then it takes a little bit of time to focus in. I kind of got it focused on the screen pretty well. Well, I just kind of want to really prove it to you. Let me see if I can do it without trying to make everything come loose. There you go. You can see my little battery power supply over here. You can see the battery up here. There you go. I do have it wireless. Now let's see if I can zoom it back down in here and get it focused in where you can see the screen here, because it's in that RGB mixed in with it. And play with there. All right, there we go. All right, let's show you real quick. Let's minimize this because I want to show you that I'm wireless and this how this works. So I'm going to type in the Pico W's address that I know it is so far. So it's 192.168.12.106. If I hit that, it's they're spinning, it's looking for it, and it's not finding it because our server is not set up yet. So let's put a little stop to that here, and we'll say that because I'll show you here in a little bit. And let's bring back up that camera, and I'm going to come over here and I'm going to turn on the power. My hand was right in the way, sorry. Ooh, I really moved it. Oh man, I really moved it. Here we go, we're doing the countdown to connect, and it says we failed, but I built in a reset button, so I'm going to press the reset button here. It's going to connect back down here, count down, and I think it's connecting this time. Let's give it a second here and see if it'll pop up. I've been having, there we go, hey, yeah, woo! We are wireless, and we just set up our own little server here. And on this Raspberry Pi Pico W, I went above and beyond what Paul wanted us to do. I am hosting an HTML and CSS, no JavaScript yet, but I'm probably going to do that here in the future. I'm hosting it on the Raspberry Pi Pico W, and that's what we're going to show here. You can see that screen. Let's see. I wonder. That's scary. I wonder if I can pull this guy over here to the side just a little bit so you can see right now. And wow, not really. Well, we're just going to shut it off here, and then I'll pull it right back up there. Let's go ahead and go to the website, and let's kick this on. And let's go 192.168.12.106. That's what it said on that screen, right? Yes, it did. So here we are. I made it really simple. I didn't want to take a lot of time. It took more time for me to learn how to add the HTML into the MicroPython than it did to put this together. I've done some HTML for a while. I've been helping take care of a couple of different churches and doing the back end. I'm not really good at design. But anyway, so now we see that we got this up. Let me switch this camera around here. I want to move this guy down here, and let's see if I can pull him back up. Hey, there he is. And you can see a little bit. I'm going to try bringing that board a little bit bigger without hiding too much of our display there. I think you can still see that. Just let me scoot over here. I'm being picky here. I'm gonna have to move this whole thing over here so we can still see our RGB. But I want to zoom this in. And oops, I knocked it out of focus, folks. I'm so sorry. Hey, there we go. Rancher network is up at 192.168.12.106, and I got the time set up. So what I did is I actually I'm doing an API on that and collecting that. I'm getting some nasty feedback here on my, I wonder if my phone, yep, my phone was getting some feedback on that screen. Alright, enough talking. Let's go back over here. You can see my mouse over here. I'm going to click on the red LED. Clicked on that, and guess what? The red LED came up, and our little SSD1306 says we got red being displayed. If I click on the green, hey, we got green displayed on the RGB. And the screen's telling us too. And if we hit the blue, cyan, magenta, yellow, orange, white. That doesn't really look too white to me. It looks like the blue's overpowering it. This is my thought. And then we can shut it off. What about that? There we go. But if you want to stick around, I'll show you the code that I did here. Let me pull that up. And I'm going to close this little window out so we can see it here. And I'm going to zoom in. You know, last time I didn't do that, and we had lots of hard time to see that really well. Let's see. There we go. There we go. I'm going to come up here to the top. Sorry. Arm itched. Importing our regular libraries that we normally do, like the machine and the SSD1306, but then up here we are including the network and the socket, and we're doing a U request. And down here I'm bringing in my credentials that can kind of hide my network connection. I learned a lot about my own home network connection doing this project. Thanks, Paul, for that. Okay, then we have our variables. We are doing our pin for RGBs, green, blue, and then we're doing our pins for our SSD 1306. Got the SDA pin and the SCL pin. And then I'm putting the frequency also in, because it's not going to change, so I'm going ahead and put it in there. And putting my screen size, putting that as a variables too. And, I was going to use this. Matter of fact, we really don't need that. So anyway, I was using that at one time, doing something else, and then replacing the text. And the text is what we're using to grab for on the get from the HTTP being sent. I was grabbing that and putting that into that list there. And then down here, we're doing our credentials for our SSID and our password. We're grabbing those. And then I had the colors ran in here as a list, and then I did a dictionary for color RGB that has the RGB colorings on it to be able to do the red, green, and blue. Then we come down here and we're setting up our object for our I2C, which is our SSD 1306. I'll just say SSD, just make it shorter. And then I'm taking that object and putting it in here and using that and describing it as a DSP, meaning for display, and then I'm calling that to call that object. There we go. Then we're setting all of the objects for the RGB using the pulse width modulator that we brought in from the library of machine. Set the red, green, and blue on those in the frequencies and turn them all off with the duty unassigned 16 to 0. Then I started the function. This is the function I did multiple, well, I think it was maybe 25 when we started playing with the SSD. This is my function to center the text. And then I found it cleaned up my function call for the color brightness for the RGB. I just got one function instead of multiple functions for like the red, green, blue. I just started playing around with it and finally got it coded right, you know. All right, here we go. Now we're finally getting down where we're setting up our network. Now we're doing, I just had a variable called WLAN, and we're using the class network with the module WLAN, and then we're bringing in the function of the STAIF. This right here is what will set up our Pico W to be able to run as the server. We could change this and have our I think it's AP STA underscore AP to have our Raspberry Pi Pico W broadcast, and so it'd be its own like Wi-Fi router in a way. Instead of connecting to our Wi-Fi router, which is my wireless Wi-Fi router, it would be its own entity as a Wi-Fi router. And so, but we're telling it to be connecting to our Wi-Fi router, and we're setting it up as a server. Then we're using that variable as an object. Now we're using that object Wayland to activate it and tell it to come on to be true. So we're telling the program that we're wanting to use it, and then the Wayland connect. This is where we're passing in our network name and our password into this. And so then we start our loop, and I do a 10 loop. I started out doing like Paul, just let it continue. But when I started going wireless, I started having problems coming up with that it would just get into a continuous loop. And that's also how I came up with being able to do a reset by my push button, because it got stuck into a continuous loop, and it was like, what's going on here? And then I did some research and found out the different codes that would pop up, and I have it coming down here where you can tell what codes are coming up. Like, I was wondering if it was timing out because the password was wrong, or if it was because I was putting in the wrong credentials for the wireless network. And I wasn't for sure, so I did some research and found this out. And then we have it come down here, and then we'll do it through the status. If it's less than 0, then it's going to continue to. It's going to say, okay, we have it, because if it's less than 0, we say it's idled, or I mean, it's not a problem. And then if we say it's greater than 3, which 3 is connected, or equal to, we're saying we're successful and break out of that loop of that. And then we're going to increment our loop from 10 down to which would be 1, and then continue back over. And then we're printing out here to the terminal down here. When I was testing this, debugging it, and it was coming down. But then I actually have it go ahead and display to the screen, as you saw earlier when we first started this. It displays to the screen. Sorry, my nose itches. And then I have a 1 second delay in between this whole loop there. And then once it comes up, if it fails, here's where it'll catch it. If it fails, and it spit out the code of why it failed right here. And well, right down here, raise runtime error, network failed, and then I'd be able to find out what's going on. And then here I have it displayed also too, because when I was in that continuous loop, I wanted to see what was going on, and so I have it also displayed on the SSD. Then if it's successful, as you saw, that the SSD will also display that we are successful in coming up, and then it'll print out here on the terminal too, and it'll give us our, as we have right down here, it'll give us our connection of our IP address also. And then we go down here a little bit more, and then we're declaring an object, and we have it set as an ADDR for the socket, and we're going to say we're going to get address info. The Raspberry Pi Pico is what I named the Raspberry Pi, its information, as where you saw it up here, and grabbing the status of that. And we're using 80 because 80 is the port to indicate for most firewalls that is a website page that you're requesting. Linux, Ubuntu. If you are running this on a Linux machine, and I know on Ubuntu because that's what I'm using here. This is 22.04. I had to go in there and change the UFW, change the UFW rules, which is the firewall rules for the Raspberry Pi, for the Ubuntu, and allow it to be able to receive and transmit the gets back and forth through my network. Just giving you a heads up for anyone who's running Linux, especially Ubuntu. I don't know about Red Hat. I know Red Hat's pretty secure too, so you might have to do that with Red Hat. Played with it a while, but different subject. Back to this. All right, we're setting another variable for the socket, and that's going to be for the object of the socket.socket, and we're declaring it in here in the socket stream is what we're being able to do. Continuous stream. I had a problem with that continuous loop, and so I found that the solution was to call it a set socket option. To SOL socket to socket so reuse address. It was giving me an address already used error code I think it was 94 or 98, and that was a solution here for that, and also to do a soft reset, which is also that I did with that button added up. Pin number 30 to ground number 28, running it to a momentary button, and that will be able to do a soft reset when you're not connected to Sony or to Visual Studio Code, to be able to do a soft reset through there. So once again, that's pin 30 and pin number 28, or I think it's GPIO 30. Before I tell you wrong, let's double check that here. It is yeah. So it's actually pin 30 because it says run and reset, and you're connecting to the ground of 28. So you got a wire coming off here and a wire coming off here, running to a momentary push button. You don't have to put any resistor in between that. It's just a quick push button. It goes takes a run and straight to the ground, and it does a momentary. It does a soft reset on Raspberry Pi Pico W when you're not connected up to like Sony or the Visual Studio Code VSC. All right, back to here. Let's get back to this. Okay, now we binded that address with the socket binding, and then we did also a listen, and we're waiting until we hear what's going on onto that address. So it sits there and it waits until it receives back a GET from what I have on my website. Why it's doing that, I went ahead and I wanted to display time on the SSD. So I'm running a GET. I'm running an API call to this right here, which is the time API.io, and I'm getting the current time in my location, America, Chicago, which I'm actually in Missouri. I'm closer to Springfield, Missouri. That would be, but that's still in the central. So, but they have in Chicago as their indication for the central time zone. And then I went ahead and it comes back as 24-hour time, and I want to convert it to just regular 12-hour time. And so here's my conversion of that, and I'm taking that and I'm converting it over down here. I'm sorry, I got mixed up with this because I did my title in between that too, which I don't know why, but I did. And then here's my conversion, and you're saying if it's greater than 12, reduce it down, so then add PM to that also. So then it converts that to AM or PM. Just thought that was easier for, I can do 24-hour time pretty well, but just in case if one of my children are playing with this, it makes it easier for them too. It gives them it just makes it easy. Just put it that way. Enough of that. Okay, then I had a message coming up with that saying that the server's up and it's listening. Then we come down here and then we enter into our main loop, and this is where we're taking us as a client and our client address. So this is our website call. So this is if we call into the Pico W, it's going to grab our address. It knows that we're coming in because we're considered as a client, and it gives our address and it says accept us. And then I'm calling it as a raw request, grabbing in and make sure we only have. Paul called it a buffer of about 1K, 1024. And I'm just calling it as raw data being sent in, only the maximum of 1024. From what I read, if it's sending more data than 1024, it will reject it. It will not receive any more than that. We have small amount of data anyway, or memory allocation on our Pico W, so I think 1024 is just perfect for it. We can do a lot with that. You can do a lot of GET, and you can actually have a small little database on that for your posting. Not too big, but just small something that you can do on there. And then I'm doing a raw request and then doing decoding like Paul showed us. I'm going ahead and decoding it to the UTF-8, and then I'm splitting that because with my GET and post, I want to be able to split that and know that, well, just right here, you know, an HTTP method will be the first part, which would be the index of 0, and then the URL would be the index of 1, and then if request is found, and then here's where we go. We'd start doing receiving the gets coming in, and then when we receive the gets, we can be able to turn on the LED. This is a really long video. I apologize. I just kind of want to, for those who are learning how to, or wanting to learn how to do this, that's why I'm kind of doing this here. When we clicked on the button, let me switch over here to HTML. Let me scroll down here. This is the header. So headers is pretty much the stuff that you do for your CSS, and I was adding in the favicon. Had no schema color, really nothing really special in there. Those who can know HTML kind of saw what I did there. Anyway, now we're coming down to the body, and here's in the body where we're doing the indication of everything that I did. It says for a label, I'm doing a red LED. It's a checkbox style. You saw the checkbox there, but then when I resent back to replace replace the holder that I have here, it would actually make the checkbox disappear. If I did JavaScript, it wouldn't, but I just wanted to do something pretty quick and simple. And then we're calling on click. We're calling a document location of the get of red LED. So then we come back to our main, and that's where this is. So it says on a request that we split down on request URL that we have, which is number 1. Being sent on that, which is, it says get, and here's what we're sending back, which is a /red_LED, and it says if it's not 0, meaning if it's nothing, but it is something. If it's something and this is what it is, then here's what we're wanting to do with it. So then we're going to, on our little SSD, we're going to clear the screen. Then we're going to run it through my function, and we're going to have it displayed the red LED. And then I'm having it display the red coming back on the website, which if we come back here, which you can see, if I click on red, you see red being displayed down here. I should have pushed that padding over. Sorry. It was smaller screen when I had side by side, and at the time it looked perfect padding, but when you actually have it fully large, which I probably need to change the meta actual CSS on that, but we're just going with it now. Okay, and then that would change it to red, and then I'm using displaying the information to the SSD, and that's what this information here is. It says you requested red, and then it's being displayed. Then we'll go down here to an elif, and we're saying that if the information that we got back in the get was a /green LED, do the same information by clearing it and then turning on the red or the green LED through our function. That's pretty much the same all the way down here to the very end, and then down here at the very end, here is where I have pulling up the HTML, which is the index.html. And so I had that setting on the Pico, and you can see it right here too. So this is setting inside the Pico. And we're saying, hey, open this up, read this information, and then go ahead and close it so you're not stuck on that function, just doing that over and over. So we got that closed out, and then we're saying, do what we do for all of this information here, and then press this and put it in my placeholder that I have right here. So then that's where we're saying like red and white, green, whatever, and then right here it's for off, like if we requested off. Like, and when we come over here and hit off, boom, it says off, and then that's what it's doing here. It's replacing that HTML, which is actually I could have done it differently, but just slapped it together here. I saw that. That's all I could do. It replace. If I did this again, I'm going to use JavaScript and make it, well, as long as it's not too big, because like I said, we have a minimum amount of storage on Pico W. But then when we're all said and done, we're going to go ahead and close it out. And thanks everyone for sticking along. If you did, this is it's almost 25 minutes long. But hey, I wanted to teach you something. Maybe if you want to be able to make a website, to host a website on the Pico W. There you go. So I think I kind of went above and beyond fulfilling the lesson number 28. It is wireless. It is not connected to the computer. It's ringing off my battery. It's hosting a web page. That's pretty much it. All right. Until next time, everyone, be safe out there.